If you take a moment and look around you right now, there's a good chance that a large part of your environment was shaped by metalworking. The chair you're sitting on, the frame of your desk, the hinges on the door, even the tools in your toolbox, all of them started as raw metal before someone cut it, shaped it, drilled it, and assembled it into something useful.
That's the fascinating part about metalworking. It's the perfect blend of craft and science, of transforming rigid, unyielding material into precise parts and structures. Unlike materials like wood or plastic, metal demands more accuracy, more planning, and the right tools. But once you understand the fundamentals, it opens up an entire world of possibilities.
Exactly. Metalworking is one of those foundational skills that supports everything from small DIY repairs to engineering projects like bridges, aircraft, and industrial machines.
So today, we're going to break down the fundamentals. We'll explore the basic tools used in metalworking, the techniques that allow you to shape and cut metal, and the essential principles that every beginner should understand before starting their first project.
Think of this as your starting point, an introduction to how people actually work with metal. When people hear the word metalworking, they often imagine sparks flying in a workshop or someone hammering red-hot steel on an anvil. And while that image isn't entirely wrong, metalworking actually includes a much broader set of processes.
In simple terms, metalworking is the process of shaping, cutting, joining, and finishing metal to create functional parts or structures. These processes can be done using simple hand tools in a small workshop or with large automated machines in a factory.
And historically, metalworking has played a massive role in human development. Early civilizations learned how to extract and shape metals like copper, bronze, and eventually iron. Those discoveries led to stronger tools, better weapons, and more durable structures.
Over time, techniques evolved. What once required manual labor and simple forges can now be done with CNC machines, precision cutting tools, and advanced manufacturing systems. But interestingly, the core principles remain the same. You still need to measure accurately, remove material carefully, and shape metal in controlled ways.
So whether you're working in a professional machine shop or just doing small projects at home, the same fundamental ideas apply. Before you even pick up a tool, one of the first things to understand in metalworking is that not all metals behave the same way.
That's right, different metals have different mechanical properties, and those properties determine how the material responds when you cut it, bend it, or drill into it.
For example, aluminum is relatively soft and lightweight, which makes it easier to cut and shape. That's why it's commonly used in DIY projects and lightweight structures.
Steel, on the other hand, is much stronger and more durable. It requires sharper tools and sometimes slower cutting speed, but it provides much greater structural strength.
Then there are metals like copper and brass, which are softer but extremely useful for applications involving electrical conductivity or corrosion resistance.
Understanding the type of metal you're working with helps determine the right cutting tools, the correct drilling speeds, and the appropriate shaping techniques.
In other words, metalworking always starts with understanding the material. Now, one of the most important steps in any metalworking project actually happens before you cut anything.
Measuring and marking.
It might sound simple, but accuracy at this stage determines the success of the entire project.
Metalworkers rely on tools like steel rulers, calipers, squares, and scribers to mark precise lines and measurements on the metal surface. Unlike pencils used in woodworking, metalworkers often use scribers to scratch fine, visible lines directly onto the metal.
Those lines become the guides for cutting, drilling, or shaping. And because metalworking often involves tight tolerances, even small measurement errors can cause parts to misalign or fail to fit together.
That's why there's a common rule in workshops everywhere. Measure twice, cut once.
Sometimes measure 3 times if the material is expensive. Once everything is measured and marked, the next step is cutting the material to the required shape or size.
There are many different tools designed specifically for cutting metal. For basic hand tool work, a hacksaw is one of the most common options. It uses a fine-toothed blade designed to cut through metal gradually and cleanly.
For faster cutting or thicker materials, many workshops rely on power tools like angle grinders or bandsaws. These tools use abrasive discs or specialized blades that can cut through steel and other metals much more quickly.
In industrial environments, cutting technologies become even more advanced. Plasma cutters and laser cutting machines can slice through metal with remarkable precision and speed.
But regardless of the tool being used, the principle is always the same. The goal is to remove material in a controlled way while maintaining the accuracy of the original measurements. After cutting, metal pieces often need additional shaping to reach their final form.
This is where forming tools come into play. Tools like hammers, anvils, vices, and bending jigs allow metalworkers to apply controlled force to reshape the material.
Some metals can be bent or shaped at room temperature, especially softer materials like aluminum or thin steel sheets.
However, harder metals may require heat to become more workable. Heating metal makes it more ductile, which means it can be bent or shaped without cracking.
That's the basic idea behind forging, where heated metal is hammered or pressed into new shapes.
Even in simple workshops, controlled shaping is a key part of creating parts that fit together properly.
Many metal components also require holes for bolts, screws, or other fasteners.
That's where drilling becomes essential.
Using the correct drill bit for metal is critical. Metal drill bits are designed with harder materials and sharper cutting edges compared to those used for wood.
When drilling metal, it's also common to use cutting fluid or lubricant. This helps reduce heat and friction, which protects both the drill bit and the material being drilled.
In more advanced workshops, machining tools like milling machines or lathes are used to create extremely precise features.
These machines allow metal workers to remove tiny amounts of material with incredible accuracy, producing parts that meet strict engineering specifications.
Once individual parts are shaped and prepared, they often need to be joined together.
There are several ways to do this. The simplest method involves mechanical fasteners like bolts, screws, and rivets.
These allow parts to be assembled securely while still being removable if necessary.
Another common method is welding. Welding involves melting metal pieces together to create a permanent joint.
When done correctly, welded joints can be incredibly strong and capable of handling heavy loads.
However, welding requires proper training and safety precautions because it involves high temperatures and intense light.
After all the cutting, drilling, and assembly, there's still one final stage that often gets overlooked.
Finishing.
During finishing, sharp edges are removed, surfaces are smoothed, and the metal is prepared for its final use.
Tools like files, sandpaper, and polishing wheels help refine the surface and remove burrs left behind from cutting or drilling.
In some cases, metal parts are also coated or plated to protect them from corrosion.
Chrome plating, painting, and powder coating are common examples of surface treatments that extend the life of metal components.
Before anyone starts working with metal, there's one topic that always deserves serious attention.
Safety.
Metalworking tools are powerful and can produce sharp edges, flying debris, and intense heat.
Safety glasses, gloves, and proper work holding are essential. Securing the material before cutting or drilling prevents unexpected movement that could lead to injuries.
And maintaining sharp, well-maintained tools is also part of safety. Dull tools require more force and increase the risk of accidents.
A well-organized workspace and proper safety habits make metalworking both productive and safe.
Metalworking might seem intimidating at first, especially when you see sparks flying and machines cutting through solid steel.
But once you understand the basic tools and techniques, it becomes a practical skill that anyone can begin to learn.
Every precise component, every reliable machine, and every strong structure begins with these same fundamentals.
Careful measurement, controlled cutting, thoughtful shaping, and proper finishing.
When those elements come together, raw metal becomes something far more useful.
It becomes engineered.
And that's the foundation of metalworking.